am Miss Anderson, and I'm going to help you with your first calculus homework assignment, starting with page 47. Number 1, I'm going to give you a little tip. The formula for distance is equal to rate times time. And we'll be using that formula throughout the entire year, so please don't forget it. The second problem I'm going to help you with is number 8a. So I'm going to start by drawing a quick sketch. All right, and a little piece of the sine curve, like so. The halfway point is going to be pi over 2. Right here we have pi. And then this whole thing is divided into 4 equal parts. This is pi over 4 and 3 pi over 4. Our maximum has a y value of 1. X-axis, y-axis. Okay, so if you'll notice, the rectangles drawn each touch the curve y equals sine x at the top right hand corner. That's very important. Okay, here's the next rectangle. It also touches the curve at the top right hand corner. The next one, top right hand corner, and there's only 3 rectangles there. Now, in order to approximate the region bounded by the curves y equals sine x, y equals 0, and x equals 0, and x equals pi, we're going to have to find the area of these rectangles. Okay, so if you'll recall, the area of a rectangle is equal to width times the length. And basically we're just going to find the area of each of these 3 rectangles and add them up. So here we go. Area of the first rectangle is equal to the width, which is pi over 4, times the length, which is the height of this rectangle. See how it goes all the way up to this curve? So that is going to be sine of pi over 4. Now, just a little reminder about what sine pi over 4 is. Hopefully you remember. But just in case, I'm going to sketch a unit circle. Okay, this starts at 0. This is pi halves, pi, 3 pi halves down here, and all the way around the circle is 2 pi. Now, pi over 4 is right here. The coordinates for pi over 4 are square root 2 over 2, comma, square root 2 over 2. If you want to know how to get those coordinates, we'll probably go over that in class, but those are just special right triangles. And if you'll recall, the first coordinate is the cosine value, the second coordinate is the sine value. So, sine of pi over 4 is the same thing as square root 2 over 2. So the area of the first triangle is pi over 4 times square root 2 over 2. And when I plug that into the calculator, I get an approximate answer of 0.555. In AP Calculus, you always want to round to 3 decimal places. Sometimes they would want an exact answer if they would want an exact answer. In this case, your exact answer would be square root 2 times pi over 8. So approximately 0.555, exact is square root 2 pi over 8. But I think I'm going to go with the approximate decimal. All right, second rectangle area is, come back over here to the drawing, right up here. Okay, the width is still pi over 4. And the length is right here. It's the height of that rectangle. That is y equals sine of pi over 2. Going back to the unit circle, pi over 2 is up here. The coordinate of pi over 2 is 0, 1. So the sine is 1. Okay, so the area then is pi over 4 times 1, which is pi over 4. If I want an approximate answer, plug into the calculator and round to 3 decimal places, I get 0.785. Okay. Area of the third rectangle. Here's that third rectangle. The width is still pi over 4. And the length is sine of 3 pi over 4. If I plug that into the calculator, I get an approximate value of 0.555. Okay, now to get the approximate area that you see here, all I do is add up those 3 areas. So the approximate area of the rectangle is, from the first rectangle, 0.555, plus from the second rectangle, 0.785, plus from the third rectangle, 0.555. When I add all of those up, I get an approximate value of 1.895. Okay, there's our approximate area under the curve from 0 to pi and bounded by the curve y equals sine x. Now the next question is, how accurate is this area? And the answer is, it's not very. It is an approximation, and it's kind of a loose approximation, because look at this rectangle goes over the curve, this goes over the curve, this one is under the curve, and look at all this white space over here. So it's not a very accurate approximation. Looks like it might be slightly an under approximation, but later in the second semester we'll actually determine the exact area under the curve using integrals, but that's later on. Right now we're just practicing approximating. And the next question is on 8b, how would you continue to obtain a more accurate approximation of the area? The answer is, you have more rectangles. So if I had 4 rectangles here, I'd have a better approximation. If I had 10 rectangles, I'd have a better approximation. If I had 100 rectangles, I'd have an even better approximation for area under the curve, but as long as you're using rectangles, you're just going to get an approximation. So nothing exact yet, but the more rectangles you use, the better off you're going to be. Okay, so good luck with the rest of your homework, and see you in class or Y-Day workshop.